Welcome to this video on the area between two functions. This video marks the start of our applications of integration. So let's make a start. I'm going to draw two functions here and we're going to look at how we can find the area between those two. So the first one I'm going to draw is going to go something like this. And the second one I'm going to draw, let's change the colour of it, let's make it green, is going to be something like this. Now, these two functions, they're not any particular function, they're just random things that I've drawn. And what we want to know is the area between these two functions, which is going to be in here. So this area in here. And what is that area? Well, we need to first find a couple of points, and these points are where the two graphs are going to intersect. So we can tell that there's a point here, and for the moment we're going to call this one A, and there's a point over here as well that we're going to call B. So how do we actually work out what these two functions here are? Well, let's first give these functions some names. So the blue one we're going to call f of x, and the green one we're going to call g of x. Alright, so the area that's shaded, which I'm going to call in this case A, is just going to be given to us by the definite integral between A and B, because the shaded area is between A and B, of f of x take g of x, which is the two functions, and of course with respect to x. We could also, if we wanted to, label them, in this case the blue one here being our upper function because it's higher, we could go yu, and the green one, which is our lower function, as yl. We could also label them like that. The textbook does label them like that in some cases. Alright, well, that's all it is, and we use our rules of integration, find the antiderivatives of both of these, and we go through and we solve it. Let's now look at an actual example of this. Alright, so what I've got drawn here is a function. In this case, the function is y equals x squared take 2x, and I want to know what is the area that I've got shaded here, the area between the x-axis and the bottom of the graph. Now, you might be saying, well, where's the second function? Well, in this case, we could say that the second function, and I'm going to call this one the upper one, so yu is just going to be equal to 0, because, think about it, when y is equal to 0, it's just along the x-axis. So if the upper y is equal to 0, then the lower y is just going to be equal to x squared take x. Alright, and this goes from 0, so it's passing through the origin here, and this point here is 2. So, let's go through and find out where, or what the area is. So, area A, it's just going to be equal to the integral from 0 to 2 of y u take y l with respect to x. Alright, so let's plug in these functions now. So, therefore, area 0 to 2, 0 take x squared take 2x. So, let's simplify this a bit further. Now, we could split this up if we wanted to using our rules for integration and split it off into two integrals, or we could just simply simplify it. In this case, I'm just going to simplify it. So, this part in here is just going to be equal to 2x take x squared. Now, why is it 2x take x squared? Well, remember, we're taking x squared take 2x, so take minus a minus makes a positive, and minus a positive makes it negative, so we're basically swapping the terms around. Now let's go through and work out our antiderivatives. So, 2x, the antiderivative of that is just going to be x squared take. Now, x to the power of 2 is x cubed over 3. And we're going to find this between 0 and 2. So, we're going to have 2 squared take 2 to the power of 3 over 3 take 0 squared take 0 to the power of 3 over 3. And therefore, our area is going to be 4 take 8 over 3 take 0. Therefore, our final answer for this our area is just going to be equal to 4 on 3 units squared. And that's really all it is. It's just following the process through and going your upper, take your lower. So the upper here, take the lower here. And following the process through. Because if you think about it, if you take your upper one away first, well, you're taking away... if you got your upper first, sorry, you're just working out the area between that and the x-axis. And then if you're taking away the lower value, well, you're just taking away the area between that curve and the lower axis. For example, and I'll draw it up on another page. So in this case here, think about it. The blue line here, or the blue function, is our upper function. So that's given to us by the area. So we're taking the area between the two intersect points. The area here is just all of this. The green area, so the area between the x-axis and the function, is the area in this part here. So if we're taking one away from the other, well, we're subtracting out all the parts where they intersect, and we're left with the bits. The only bits that are left are where the area between those two functions. Hopefully this video has made a bit of sense. I'll show you guys in class how to do this, on how to work it out on your calculators as well. Once you've got to a certain point, you can then just plug it in and get your answer. So, hopefully you've got something from this video. If you've got any comments, just ask, or any questions, just ask. As always, thanks for watching, and we'll see you next time.